All right, hello. My name is Brian, and I'll be the final lecture for today in the Green Affair. Thank you all for coming. Honestly, compared to last year, this is a real big difference, and I really feel very special that all of you took the time or were forced to be here today by your professors. I'm a senior here at Paterson University. I'm an environmental science major, and I come from a country in South America. It's called Bolivia, a landlocked country. And when you're from a landlocked country, you know the importance of water and what it is, not only a vital resource to food, to life, but also for agriculture and a lot of different ways we use it, especially now with improvements in different types of energy, hydroelectricity, and those things. Can you guys hear me in the back? Good? All right. So this presentation that I'm doing today is about how climate change is affecting the tropical Andean glaciers. We hear about a lot of glaciers that are in Africa, some that are in Swiss, but tropical glaciers in the Andes Mountains are a little different because they're glaciers that really shouldn't be there. They're in a part of the air, in the earth that's really warm around the equator, as you'll see in the presentation. So they're very susceptible, they're very weak when it comes to changes in climate. So we'll start now. If you can't see, we can lower the lights, I guess. You guys good back there? All right. So let's start first with the Andes Mountains. It's a mountain range that is the longest continental mountain range in the world. It's about 4,300 miles long. Average height is about 13,000 feet. And it extends north to south through 7 different countries: Argentina, Bolivia, Chile, Colombia, Ecuador, Peru, and Venezuela. And it's home to about, well, almost 100% of the world's tropical glaciers. Tropical glaciers being, like I said, they're between the Tropic of Cancer and the Tropic of Capricorn, which is 30 degrees north and south of the equator. So, tropical glaciers, some more facts about them. Located on the warmest part of the planet, seasonal changes is minimal, warm all year round, not ideal for snow to accumulate. Few mountains are tall enough where the air is cold enough for the maintenance of a glacier, and the glaciers located in the tropics are on high isolated mountain peaks. So they're the top, the white part of a mountain, the very top. So the Andes and climate change, like I said, they're the most visible indicator of climate change due to their fast response time, sensitivity to climate variations. They're very commonly called the canary in the coal mine. When they see a small change in temperature, you can see it visually. They're either melting or they're advancing. So some of the most famous glaciers that have been recorded are in Ecuador, Peru, and Bolivia. This is the Antizana. This is in Peru, the Cordillera Blanca, and then in Bolivia, the Cordillera Real, which are the most studied glaciers, some of which have already gone. They're completely disappeared. So in a lot of the facts I'm going to be talking about, you'll hear these names coming up again. And this is where they're located. So I wanted to take a look at the past, present, and future of what the Andes, of the history of the Andes, the future, what can happen, and then the present, how they got to where they are now. So the past segment is the glacier variation since the Little Ice Age. This chart here is a change in length and surface area of 10 tropical Andean glaciers between 1930 and 2005. As you can see, the trend is going down. Again, there you see Antizana, you can see Chacaltaya right there. A lot of these have gone down. You see some positive going up, like this one here, but it just depends on where that glacier is. Some of them are closer to the equator, some of them are a little higher, so yes, you can see some positive ranges, but the overall trend is going down. So Albert Einstein once said, "It would be possible to describe everything scientifically, but it would make no sense. It would be without meaning, as if you were to describe a Beethoven symphony as a variations of wave pressure." So for that, I used some pictures to illustrate what's happening in South America, or what has happened. Antizana in Ecuador in 1872 into 1903. Okay. As you can see here, the small patch has gone back. Ecuador, then we move on to Peru, Pastoruri in 2001, 7, and 9. Jacobamba in Peru as well, 1980 and 2009, almost completely gone. It's an interesting one. It's the Brogy Glacier in the Peruvian Andes. A small photograph here. It's in black and white, but you can see the small little slither of that used to be this giant glacier that used to occupy this area right here. Now it's completely receded up. And this picture was in 2000. And the photograph was taken in 1932. Charquini Glacier in Bolivia, they were able to date this one back to 1679, has retreated a lot over time, and here we are, the last recording of this picture was in 1860. This next one is of Chacaltaya, these few pictures. This is actually one of the glaciers that I lived near when I was in Bolivia. My family still resides there. This was one that I've mentioned before that was completely melted and hasn't made a comeback since 2005. So this was it in 1980. It was a interesting fact about it. It was the first ski resort in South America and the highest ski lift and the first ski lift to be created over there. It was used for skiing. This was in 2005, actually the year before it completely melted. A lot of people said that it was its last, I guess you can say, hoorah before it actually went later on that year. And this is it now. This picture was taken by Natural Geographic. It almost looks like a very cemetery type scene. It's pretty much abandoned now. No snow goes there, even on the coldest of days. Again, where people used to go skiing down. The ski lift obviously is useless now, but it's a good memory of what used to be there. Again, 1980 to 2010. And the point of all this is not that we can't go skiing the world's highest ski resorts anymore. It's the water that actually fed into the valleys and streams that supplied this resource to small villages and farther downstream to the main capital, which was La Paz, Bolivia. So next to Chacaltaya, there's its sister mountain, Zongo, which is higher in elevation. Well, the tip is higher, so you can see that there's still a good amount of snow at the top. This picture was taken in July of 2008. That's satellite imagery from Google. Although it is higher and it looks like it's doing really well, they have studied it. In 2004, this ice used to touch this river here. In 2008, it's beginning to recede farther away from it. So the present, we look at how did we go from those pictures in the before into now? What happened? What changed? So to accurately connect the glaciers, we looked at what climatic forcing happened within the 20th century. Obviously, temperature is one of them. Using temperature reporting stations along the Andes between the tropics, they were able to look at what happened, and the overall temperature increase was 0.68 degrees Celsius. Again, not a huge increase, but this is overall in all the Andes, from north to south. And like I said before, the tropical glaciers are unlike any other glaciers where they're super sensitive to any positive or negative changes. And overall trends in the, this is the temperature of the air temperature around the Andes. Again, average of all of the Andes, the whole strip of it. Overall trend is increasing. Although you do see some ups and downs, overall trend is increasing. This study was done in between 1939 and 2006. Precipitation is another one. It's important because it's how the glacier recharges. In one study, 42 stations were used that contained data between 1950 and 2000 to begin analyzing trends. But unfortunately, those 50 years is not enough data to produce a long-term trend to be able to model what's going to happen in the future. But from those results, they were able to determine that Ecuador and Peru had an increase in precipitation, while certain areas in southern Peru and in Bolivia, they had a decrease. But again, more information is needed to make better understandings. And another thing, well, you'll see in the next slide is, well, humidity. It's another factor that can cause these glaciers to either retreat or advance. Changes in humidity are very relevant to the glacier variations because of the impact it has on the distribution of the available energy into meltwater, well, ice to water, or into sublimation, which is ice directly to vapor. But unfortunately, there's no data for that humidity. The reason for this is because the Andes is in such a remote location. Even though they do have a big population that live there, it's mostly indigenous. They don't have the equipment, nor do they have the tools to be able to record any type of data, or accurate data for that matter. So this is why in a lot of these factors, there's not enough information or data to be able to determine any future trends. Another factor that was studied was El Niño and La Niña events. What those are is El Niño is a warming of the ocean, sea surface temperature along the coast of South America and North America. And La Niña would be the opposite. It would be a cooling of the Pacific coast of South America and North America. So during these events, they've noticed that they looked at Zongo, Chacaltaya, and Antizana. And what they noticed is that during El Niño events, you had more decline. El Niño would be the red, I'm sorry, the red boxes will be El Niño. And La Niña, they noticed during these events, you had either a balance off or an increase. So obviously there was not enough data to prove that this is what was forcing it, but it's an interesting fact to look at. During these events, these are the only times that it balanced off and increased. So the way to determine the glacier mass and energy balance is the difference between the frozen precipitation accumulation and the ablation, which is the sublimation and melting. So pretty much the difference between when it's melting or when it's accumulating snow and getting bigger, advancing. A glacier with a negative balance is out of equilibrium and will retreat, and obviously with a positive, it'll have the opposite effect and will advance. Unlike mid-latitude glaciers that experience summer and winter, these experience summer and winter all the time. Being that they're near the equator or in that area of the tropics, they're continuously melting and freezing at the same time. That's what makes them so easy to fall out of equilibrium, is that because they're in an area where they shouldn't be. And these whisker box plots are the monthly mass balance for two mountains. A would be Chacaltaya, and B would be the Antizana. So as you can see, throughout the year, there's a balance. It goes down, it goes up. And in this one, Antizana, because it's in a different part of the Andes, farther away, this Antizana is in Ecuador, so it's a little farther away from the equator. You can see there's not much variation. It remains kind of stable throughout the year. And this one is closer to the equator. So as you can see, during some time of the year, it does experience a little bit more, but overall it balances out again. I'm not going to go too into this. To surface energy balance is how they get all the information to come out with this number as to where the energy is going, as to what's forcing it and what's taking away from it. It includes a lot of information like the shortwave radiation that comes in, the surface albedo, and a lot of other things. It took me a while to get my head around it, so I won't go too much into it for this lecture. But this would be the equation that they use for it, and some of the variables that they use for that. So for future, projected 21st century climate change, studies have grown now. More people are looking at what's happening in the Andes, and they're focusing more on temperature and precipitation. As I mentioned earlier, there's not enough data there from past historical data, but now that they're beginning to collect it, now that they know the importance of it, they're going to start looking at that information for future. So all this comes down to, I guess, why the Andes matter. The Andes are a vital region for the majority of the population in countries and economies. It has a population of about 85 million, with the northern Andes in the most densely populated mountain regions in the world. So 85 million people live on the actual mountain, on the mountain range. And then you have an additional 20 million people that live below it, but they still rely on the freshwater resource that it holds, that it gives. But it's a lot of people. Obviously, the most important is the water supply from the Andes. Snow and glaciers are contributing meltwater to many rivers along the Andes with benefits to indigenous communities, forestry and agriculture, mining activities, hydroelectric power, and tourist activities. When Chacaltaya first went in 2005, they looked at what effects it had on not only the water resource but also the community. And so this glacial water scarcity casualty loop was made. Briefly getting into this diagram now, we'll get into each one in a little bit. Climate change had an effect, a positive forcing on glacial melt. And then the glacial melt had the effect on the water availability. The water availability had its negative effect on the economic prosperity and also the food supply. And when you have these two problems, you're looking at migration, people getting out, either looking for new water resources or looking for different places where they can thrive and raise a family. And then when you have migration, you put more stress on the new area that you go to. If it's one glacial that went, you look for another glacier that's giving fresh water, and then you put more stress on that one. So not only do you have internal ethnic tension within the country, but you could also have regional tension when you leave one country to go to another. And we'll go into some of these in more depth right now. So retreating glaciers, when they start melting, well, first what happens is that you have an increase in water flow going to these cities. It might be good and all for a little bit, but then you have an increased amount of water that causes flooding. In this picture here, you have an interesting effect. You have small rivers that form, or small bodies of water that form at the bottom of a glacier. And then what can happen is these large, giant chunks of ice can crack off because of the melting and fall into these bodies of water. And it's just like throwing a piece of ice into a very full glass of water. You're going to send all the water running out, rushing down a mountain, picking up mud, and causing either floods downstream or mudslides. This has happened, and many villages have been destroyed in Peru and in Bolivia because of this effect. They cause flash floods, and another thing too is that when this happens, you could also not only cause water to rush down, but also these large chunks of ice can coming down, almost like an avalanche effect. And these large chunks of ice, as they pick up speed, can be very dangerous to any villagers or anybody down on the bottom of the mountain. Then after the period of floods and a lot of water melting, you're going to have periods of droughts. And then these glacial water makes up a large percentage of the river flow in several key locations. So if you start getting an increase, then you're eventually going to get a decrease in the water. And droughts can occur. They have occurred in many places because of these glaciers that have completely melted off. Loss of hydroelectricity. This is an interesting one because hydroelectricity, even though it's not as common here in the United States, it's used very much in South America for electricity. So in the beginning, like I said, you're going to have an increase of water melting. So communities are going to start investing in these hydroelectric plants to be able to turn that increase of water into power. And then when you have a time of drought, you're going to have no electricity. The plants that you invested in won't be worth anything. And then you're also going to need more electricity to, the demand is going to be higher for. This graph shows, the red bars show by each country how much hydroelectricity as a total the country uses. And the blue is how much it gets just from the Andes Mountains. So if you're confused here about Venezuela, they use a good amount of their electricity is from hydroelectricity, but they don't get it from the Andes Mountains. That's why you don't see a blue bar next to it. They get it from a different mountain that's not part of the Andes Mountains, and they could also get it from different parts of the ocean as well. So one of the consequences of losing hydroelectric power is that these countries may have to turn to fossil fuels for energy, which will create a feedback loop that increases the greenhouse effect that put them in the melting glacier position in the first place. So plans for renewable energy in the Andes are in progress, but as of now, because of the economic situation and the countries that these problems are occurring in, only about 1 to 3% of its electricity is from renewable sources, and that's only wind and solar. And then, as I mentioned earlier, this can cause displacement. Small communities in the Andes are facing water shortages that can cause them to migrate to other areas to survive. This puts, like I said, more pressure on the other glaciers that they go to, more pressure on other communities, looking over for work, looking over for food, looking over for water in that fact, and space to live. So all this ties into what can happen after these glaciers have gone. And then you have another topic that I won't go too into now, but you can actually have wars over water. There have been many wars over water, especially here in the United States, in the western part of the United States. But you do have some occurring now in India. You had one in South America, Bolivia. And although they're not, it might sound crazy, there have been wars fought over oil, and now we're going to face some wars over water. As they, like I said, as they disappear, they're going to put, the demand for it is going to be higher, and it's going to put stress on different locations. So unfortunately, the Andean countries do not have control over their own future. Climate change is a global problem, so even if Bolivia, Colombia, Ecuador, and Peru were to transform themselves into models of renewable energy production, they would still be affected by the CO2 emissions of countries halfway around the world. And so not only are these glaciers a way of storing fresh water around the world when we need it, but they also release it at the right time too. In the winter, they store it when we don't need it as much, and in the summer, they slowly melt it away, giving it to us when we really need it. So the loss of these glaciers, as you can see, has an effect, a long-term effect, into the communities, into the country, into the economy. It's not just the loss of water that we can't drink, or that we can't go swimming, or that we can't go skiing. There are other factors that plays into why the Andes are important. And I've been doing this talk now to raise awareness of what's happening in South America. I know a lot of different documentaries have touched a little bit on South America, but not too much. You mostly hear about climate change and how it's affecting us here in the United States. But when you really look at third world countries, or second world countries, or as they like to call them now, developing countries, or underdeveloped, you can notice the change is harder. In the summers here, we can turn on an AC, or we can go when there's a drought, so we're not allowed to drink the water. We can go and buy fresh water bottles and drink from there. In other countries, you have to look for shade. Or there's fresh water. As you can see, if the water is gone, you have no way of getting any of these resources. And because of these economies, they don't have the types of amenities that we have here. So although climate change is happening all over the world, some places are feeling it harder than others. And that will conclude my lecture for today. Thank you very much for all for coming.